Find the maximum and minimum normal stress at the point P of the circular rod. This is the point P over here. This point P. This is point P. Now, external load is a torque. You see, there's a force F, distance D, this is a torque, you see? Now, if you isolate this circular rod, you see here, you see, you have a torque like that, you see, there's a torque, and in the opposite direction, here's the torque, okay, like this. And you have the reaction, is a torque like that. So this is a wall, okay? Now this is fixed into the wall. Now let's analyze this element of here, okay? This XY, this is unprimed system. So sigma ij is equal, look, 0, 0, minus tau, and minus tau. You see? There is no normal stresses. Now, let's follow two ways, okay? The first one is find eigenvalues and eigenvectors. Let's start doing this, of this matrix here. So, let's determinant of 0 minus lambda, this is minus tau, this is minus tau. Tau is known, okay? Tau is known. Now, tau appears, okay, from the external load, the torque. This is 0 minus lambda. So determinant must be equal to 0. So this will be lambda square minus is plus. So in this direction is minus. Tau square is equal to 0. So lambda 1 is equal, sigma 1 is equal tau, and lambda 2 is equal, sigma 2 is equal minus tau. You see, because there's a square root, you see, lambda square is equal tau square. So the roots are sigma 1 and sigma 2. Now let's find the eigenvector, okay, corresponding to these eigenvalues. Lambda 1 is equal, sigma 1 is equal plus tau. Now remember, see, 0 minus lambda, you see, now we'll solve the homogeneous equation, see, 0 minus lambda, so this will be minus, let's put here, okay, look, 0 minus tau, you see, now this is minus tau, this is minus tau, and this is 0 minus tau, okay, this is a homogeneous equation, let's put A and B, this will be 0. See? The definition of eigenvalue and eigenvector. So this will be tau square, you see? Now this, the determinant, okay, will be tau square minus, so determinant here will be 0. You can see here, look, minus is plus tau square. Minus tau square is 0. So the determinant must be 0. And for us to have many solutions, non-trivial solutions. So this is clear here. Now, let's solve here. Minus tau A minus tau B is equal 0. The same here, okay? The same equation. So tau is different from 0, so you can simplify. So from here you have minus A minus B is equal 0. So A is equal minus B. You see? Now, P1, the first eigenvector will be, let's put here A is equal 1, so B is equal minus 1. You'll be here 1 and minus 1. Okay? Now, let's obtain A2, let's write here. Let's write right here. See? Now let's get the second eigenvalue. The second eigenvalue is, let's put here, item A2 is lambda 2 is equal, sigma 2 is equal minus tau. Now, remember that sigma ij here is 0, 0, minus tau, and minus tau. See? This is 0 minus lambda. This is 0 minus lambda, minus tau, and 0 minus lambda. So lambda is negative. So 0 minus lambda, this will be tau. See? This is minus tau. This is minus tau. 0 minus lambda is 0 minus tau. So plus tau. Let's solve this homogeneous equation here. So this is 0, 0. Now here, A tau minus B tau is equal 0. Let's cancel. So A is equal B. Now, the second eigenvector could be 1, 1. See? 1, 1. Now let's draw this. Let's draw. So, the eigenvectors P1 and P2. You see, P1 is 1 minus 1. 1 minus 1. It is P1. This corresponds to sigma 1 is equal plus tau. And P2 is sigma 2 is equal minus tau. Is 1, 1. So 1, 1 is P2. Now, what is important here in this drawing is this is the initial. This is sigma ij prime. Now, look, this is a normal stress. Sigma 2 is equal tau, but you see you have to pay attention. The arrow of the sigma 2 is the negative position. So sigma 2 is equal minus tau, is over there. And sigma 1 is plus tau. This is a normal stress, normal stress. This is traction, this is compression. This is the initial, you see? The initial, this is sigma ij. You see? Minus tau, minus tau. Look, here there is no normal stresses. So, this is item A. You see? That's a solution. Item A. Now, let's go to B. Another way to calculate the normal stress. So, this is sigma x prime. This is the formula. Sigma y prime. And tau x prime y prime. And this is the angle, this is the angle in which if you plug 2 theta p in sigma x prime and sigma y prime, we will find the normal stresses. So let's calculate this angle over here. You see, these are the input data. Sigma x is equal to sigma y is equal to 0. Tau xy is equal minus tau. So xy plus sigma x plus sigma y over 2, this is 0, this is 0. You see, this is 0 over here. Now, tau xy, you see, tau xy sine of 90 degrees. Why? Because, you see, tau xy is minus tau divided by 0. So this angle over here must be 90 degrees. So 2 theta p is 90 degrees. So this is sine of 90 degrees, which is 1. And tau xy is equal minus tau, you see? So sigma x prime is equal minus tau. Let's put here, you see? This is equal minus tau. Now, sigma y prime. This is 0, see, because this is 0, this is 0. Now this is minus tau xy sine of 90 degrees, which is 1. This is minus minus, so this is plus tau. Plus tau. So sigma y prime is plus tau. Now, tau x prime y prime. This is 0 because sigma x, sigma y is 0. Now, attention now here, you see, 2 2 theta is 90 degrees. Cosine of 90 degrees is 0. So tau xy will be 0. So let's see all these two results. The same result, okay? But the procedure are different. Now let's see. You see here is x prime. This is minus tau. You see the arrow here? This is minus tau, sigma 2. This is x prime over here. You see P2? P2 is related to minus tau. This is P2. This is x prime. Now, sigma y prime is plus tau. You see sigma y prime. This is sigma, let's write here. This is equal sigma y prime. This is equal sigma x prime. Now sigma y prime is plus tau. You see plus tau. You see the arrow here is plus tau. And obviously there is no shear over here. You see? So we came from xy, x, and then we came up with x prime and y prime. The same result and the same result over here. So here there is no shear. You see? The shear for sine of 90 degrees is 0. It is not 0, this is 1, but this part here, sigma x minus sigma over 2, this will be 0. So this is 0.